Hello everyone! Today I will talk about analyzers. You will learn how they are used to analyze text before indexing documents to an index. How are they used when searching for documents and the component that make an analyzer. Say that we have some documents. We extract the text from them. An analyzer basically processes text during indexing and searching. The output of an analyzer are a set of terms which we call tokens with their corresponding document. Analyzers make searching efficient and accurate. An analyzer is a combination of three components. Character filter, this one is not required and you can specify more than one character filter if you wish. Tokenizer, this one is required and you should specify just one tokenizer. And finally, the token filter. This one, it's like the character filters, it's not required and you can specify more than one token filter. And by combining these three components, we form an analyzer. ElasticSearch provides built-in analyzers. They provide ready-made options for processing text in various ways, and some of them are designed for specific types of data. Here are some common analyzers. We have the standard analyzer. You can see that this one does not have a character filter, but it contains the standard tokenizer and the lowercase filter as well as the stop filter as token filters. We have the simple analyzer. Here you can see that we had the tokenizer, but we don't have any character filters nor token filters. Whitespace analyzer is the same, but it uses the whitespace tokenizer. Finally, we have the stop analyzer. This one lowercases the tokens and removes stop words. And we have more. You can check the documentation to see a full list of built-in analyzers. As I told you in the beginning, analyzers are used when indexing and searching for documents. Let's start with the index time analysis. First, you start with your documents. You pass them to the tokenizer. The tokenizer outputs the individual tokens. These tokens are filtered by the token filters component and then stored in the inverted index. Now, when searching, we start with the query. The query is separated into individual tokens by the tokenizer and then filtered by the token filters. Finally, we search in the inverted index to retrieve the documents that match the query. If you want to read more about the three components of the analyzer, check out the documents. You can click on each one of these images to read more about the character filters, the tokenizer reference, and the token filters. Also, check this Medium post. I used it a lot as an inspiration when making this video. I think you will like it. Again, just click on the image and it will open the Medium article for you. Now let's go to VS Code to see how to implement this. Open notebook number 24. If you want to read more about the Analyze API, please click on this link. And if you want to get access to the notebooks as well as the slides, you will find a link in the video description that will take you to GitHub. When you go there, feel free to clone the repository and enjoy. The first thing we need to do is to connect to ElasticSearch. Then I will start with the character filters. Here, if you want to read more about them, please click on this link. Let's start with the first one, which is the HTML strip character filter. Here we use the Analyze API and here we specify the character filter. So here we are not indexing anything, we are just experimenting with the character filter. So here is my initial text. Let's say that we extracted this from a document and we want to pass this to the character filter. So this one is built into Elasticsearch and it will remove any HTML tag. Okay, so let's see how to remove this, or basically let's run this. And as you can see, now we have been able to clean this text. So we no longer have the B tag and we no longer have the P tag as well as this. So now it is cleaned. I'm so happy. So this is how the character filter works, or the HTML strip character works. Okay, let's go to the mapping character filter. This one is straightforward. You just map a set of characters to another set of characters. So here we are mapping the Arabic numbers to their Arabic Latin representation or equivalent. So this is 0, 1, 2, etc. And if we find this in any string, we will basically map that to these numbers. So this is what I did here. So I saw commit Sushinshan Atlas in 2024. So this one should be replaced by these digits. Let's see. We mapped these digits into the set that we have defined here. So this is how you use the mapping character filter. So I just took 2 built-in character filters, but if you want to read more, please click here. Now let's go to the tokenizer. Let's start with the standard tokenizer. Again, you use the analyze API, and here instead of using the character filter, you use tokenizer. And again, you have to specify the input text. So here, let's see how the tokenizer works. Basically, the tokenizer will take the sentence and split it into individual words or individual tokens. In the response, we get the tokens from here, and after that, we can just loop over them. Let me run this to see what we will get. You can see that the first token is the. Then we got number 2, quick, etc. And you can see that the case is not changed. For example, quick is uppercase, jumped is lowercase, etc. And here you can see the type of the token. So Elasticsearch tries to analyze the tokens for you. This is why we say that when we index documents, Elasticsearch tries to analyze the content of the documents. For example, the is a string, so it's alphanumerical. 2 is numerical, which is correct. And the rest is the same. Now let's see the difference between the standard tokenizer and the lowercase tokenizer. Basically, we have the same code. We just changed the tokenizer to lowercase. And if I run this, you can see that the tokens are lowercase. And this one will try to remove any numerical digits. Basically, in this case, we removed number 2. So this is how it works under the hood. Let's see the white space. This one will try to split the sentence or basically the string by the white space character. In this case, brown foxes will be 1 token. Let's see. Yeah, so this is just 1 token because we told Elasticsearch to split this sentence by white space. Now let's move to the token filters. Token filters basically take the output from the tokenizer, as you can see. So first you need to use a tokenizer, and then you tell Elasticsearch how do you want to filter those tokens. So here I want to filter them by apostrophe. So this means that I will remove this. Okay, so if I run this, you can see that everything is correct. Everything is like before. But when we arrive at dogs, you can see that we keep dog, but anything that comes from after apostrophe will be removed. So this is how the token filter works. Let's see another example of a token filter. So here I am using the decimal digit token filter, and this one will work basically like the mapping character filter that we have used before. It will convert any numerical digit into the standard one, which is basically the Arabic Latin representation. So you can see that 2024 was converted to this. We have the reverse token filter. I mean, I don't know why you would use this, but I'm just showing you the built-in token filters that are inside Elasticsearch. You can see that we took, for example, I saw it was reversed to was, comment it was reversed to this, etc. Finally, we arrived at the built-in analyzers. As I told you in the slides, analyzers basically combine the 3 components: character filters, tokenizers, and token filters. If we use the standard tokenizer or analyzer, so you see here we are using analyzer instead of filters or tokens or tokenizer, etc. because analyzer basically groups all those 3 components. So we use the standard analyzer, and let's see what it does. You can see that first it lowercases the tokens. So this is a character filter. So here basically we have a lowercase filter, and we split the tokens by using the standard tokenizer. We have the stop analyzer. This one, it will lowercase the tokens and it will remove any stop words. Let's run this. Let's see. So here I saw commit Sushinshan Atlas in. So it removed in and it removed 2024. So you can experiment with these to see which one will suit your use case. And here we have the keyword. The keyword analyzer is a little bit different than the other ones. So basically it will take the whole sentence and return it as a token. You can see that here I'm trying to loop over the tokens, but I'm basically getting the same input back. So this is how the keyword tokenizer works, or analyzer works. Basically, if you have, let's say, product IDs and you want those to be considered as a token, you can use the keyword analyzer to basically take that whole string as a token and not split it into multiple tokens. Finally, I told you that the analysis is done both in the index time and search time. Let's explore the difference between them. Here I will be creating an index called index time example. First, we set up the mapping where we define a field called content of type text. This field is configured to use a custom analyzer, which we specify in the settings dictionary. Within settings, we define an analysis phase to customize how the text is handled. To begin, we add a character filter named ampersand replacement, which basically maps the ampersand symbol to the AND string. Next, we create a custom analyzer that I named custom index analyzer to make it simple. Here we are setting the type to custom to tell ElasticSearch that we are creating a custom analyzer. This analyzer, so here are the three components. The first one is character filter. We are using our custom character filter as well as the built-in HTML strip character filter. We are using the standard tokenizer and the lowercase filter token or token filter. Okay, so we take this and then we create the index. Here I have a document and finally I will index that document to the index. Okay, let's do this. Great, so here it says successful, which means that we were able to index the document successfully. Now what happens if I try to search for that document? So here we are going to use the search method and we are going to match everything because we have just one document. And here you can see that the text did not change. We still have the ampersand symbol. This does not mean that our custom analyzer did not work. This is expected because Elasticsearch stores the transformed tokens in an inverted index for searching purposes, while keeping the original document intact in the source field as we get. Because if you want to retrieve back the document, you want to retrieve the original document, not the one that was transformed because of the analyzer. I hope that this makes sense. And just to let you know that this is working, we are going to use the analyze method. We are going to provide it with the same document. And here you can see that by using the index name, we are going to use the custom analyzer because here we did not specify it. Now, look what happened. You can see that here we have visit my website. Here we have the website link. And you can see that the ampersand symbol was converted to the AND string, which means that the analyzer is working. Unlike the index time analysis, search time analysis only transforms text when a query is performed. In this example, we will perform a search on the content field using the match query, which is ideal for full text searches. Here you can see that we are using an analyzer called standard. Basically, when you are in the search time phase, you can use any analyzer that you want. It does not need to be the same one that you used in the index phase, but be careful. When you change the analyzer, you might get different results. Here, for example, I know that this link exists or that this token exists. So if I search, it gives me the document. Great, because you can see that this is a token that we got back and we can use that to find the document. But what happens if I use, so this is the match query, which is used for full text search. But remember, when you use term, the token has to exist. If you provide a token that does not exist, you will get nothing. We saw that this one exists, but if I try to change the case of the text, you can see that this time we get nothing because term is used for exact matches. But if you use match, then Elasticsearch will see that this one is very similar to this one. The only difference is that this one is lowercase, but the other one is uppercase. So basically they are similar, but when you use term, this does not apply. Use this if you want to get exact matches. I hope that this makes sense. We arrived at the end of this video. I hope that it was helpful. Please, before leaving this video, leave a like and subscribe to the channel. See you next time.